Hello. Today we are going to be talking about derivatives. A derivative measures the instantaneous rate of change of a function. In simple terms, it's the slope of the curve at a single point. For straight lines, finding the slope is easy. It's just rise over run. So for this straight line, the gradient is going to be rise over run, or the change in y over the change in x. To get the derivative, we first look at the average rate of change between 2 points, one at x and one at x plus h. Now this is more useful to find the slope at the point for curves. We use the difference quotient, which is f of x plus h minus f of x over h. This gives us the slope of the secant line, which is the line joining the 2 points, as shown below. But 2 points only gives us an average slope. To get the exact slope at one point, the second point must move closer and closer to the first. So we are letting the h approach 0. And that gives us the official definition of the derivative, which says that the first derivative is equal to limit as h tends towards 0, f of x plus h minus f of x over h. This also gives us something known as the gradient function, which I will go on to describe in an exam question, a practice question. So here we go. The function of this curve is f of x is equal to x squared plus 5. Find the gradient of the curve at point A. If you want to, please pause the video and have a go at this question. Okay. So first of all, we write down the formula to find the gradient function or the first derivative. Next, we substitute. Here, when we are saying f of x plus h, we take our original function of the curve, which is f of x is equal to x squared plus h plus 5. And wherever x comes up, we substitute x plus h in its place. So x plus h whole squared plus 5 minus x squared plus 5. The brackets must be around x squared plus 5 because the original formula states that it's minus f of x. Now let's ignore the limit h tends towards 0 part. Let's expand the part within the curly brackets. That gives me x squared plus 2xh plus h squared plus 5 minus x squared minus 5 all over h. Now we can cancel out x squared and minus x squared, and we can cancel out plus 5 and minus 5. Now we are left with 2xh plus h squared over h. Now let's take the h's out and let's cancel them, as shown in this step. Now we are left with 2x plus h. But before we said that h needs to tend towards 0, so let's take h is equal to 0. So now the first derivative is 2x. The gradient function is also 2x now. And if you go back here, we see that the x coordinate of point A is 3. So all we need to do to find the gradient at point A is to substitute 3 as the x value into 2x. So the gradient at point A is 2 times 3, which is 6. Thank you for listening to this video. If you find my explanation helpful, please like the video. Thank you very much.